Hello dear students, myself Ganga Bhosle, your statistics teacher. Today we are going to learn examples of Poisson distribution, that is example number 5. Assuming that on an average 1% of the output in a factory making certain part of an article is defective and that 200 units are in a package. Find the probability that first one, at most 2 defectives, second, at least 2 defectives may be found in the package, and also here given that e raised to minus 2 is equal to 0.1353. Okay. Here we have to find out probability for at most 2 defectives and at least 2 defectives in the package. Okay. First we find out the value of m, that is mean. Here 1% of the output in a factory making certain part of an article is defective and there are 200 units in a package. So, here we get mean is equal to, which is equal to m, which is equal to 200 into 1%, that is 1 divided by 100, which is equal to 200 divided by 100, which is equal to 2. So, here we get m is equal to 2, that is mean. Then we first find out probability for at most 2 defectives, at most 2 defectives. So, here we have to find out probability for the values x is equal to 0, x is equal to 1 and x is equal to 2, that is probability for x is equal to 0, that is there is no defective, no defectives. Plus probability of one defective, that is for x is equal to 1, plus probability of 2 defectives, that is for x is equal to 2, okay, which is equal to, for x is equal to 0. First here we write down the formula p of x is equal to e raised to minus m raised to x divided by x factorial, okay, that is here p of 0 plus p of 1 plus p of 2, which is equal to for x is equal to 0. Here we get e raised to minus m, that is 2. For here m is equal to 2. So, here we get e raised to minus m is equal to e raised to minus 2 into m raised to x, that is 2 raised to 0 divided by 0 factorial, plus here we have to find out p of 1, that is here x is equal to 1, then we get e raised to minus 2 dot 2 raised to x, that is sorry, x is equal to 1 divided by 1 factorial plus e raised to minus 2 into 2 raised to 2 for x is equal to 2 divided by x factorial, that is 2 factorial, which is equal to e raised to minus 2. 2 raised to 0 is 1, 0 factorial is 1. So, here we get e raised to minus 2 plus e raised to minus 2 as it is 2 raised to 1 is 2, 1 factorial is 1. So, here we get only 2 into e raised to minus 2 plus e raised to minus 2 as it is into 2 square, that is 4 divided by 2 factorial, that is 2 into 1, which is equal to 2. So, here we get 4 divided by 2 is equal to 2. So, 2 into e raised to minus 2. Common out e raised to minus 2 from this equation. So, here we get e raised to minus 2 into 1 plus 2 plus 2, 1 plus 2 plus 2. Which is equal to e raised to minus 2 into 1 plus 2 plus 2, which is equal to 5, which is equal to 5 into, here in question value of e raised to minus 2 is 0.1353, 0.1353, and when we multiplied 5 by 0.1353, we get 0.67667, 67667. That is, this is our probability that at most 2 defectives in this package. And now we have to find out at least 2 defectives may be found in the package. Second one. Second, probability at least 2 defectives, probability at least 2 defectives. So, here we have to find out the value 1 minus probability for no defective, that is for x is equal to 0 plus probability of 1 defective, that is x is equal to 1. Which is equal to 1 minus, here the value of x is 0. So, we get e raised to minus m, that is m is equal to 2. So, here we get e raised to minus 2 into 2 raised to 0 divided by 0 factorial plus e raised to minus 2 into 2 raised to, here x is equal to 1. So, we get 2 raised to 1 divided by 1 factorial, which is equal to 1 minus 2 raised to 0 is 1, 0 factorial is 1. So, you get e raised to minus 2 plus 2 raised to 1 is 2 divided by 1 factorial, that is 1. So, here we get 2 into e raised to minus 2, which is equal to 1 minus, here from this equation we common out e raised to minus 2. So, here we get 1 plus 2, then 1 plus 2 is equal to 3. So, here we get e raised to minus 2 into 3, which is equal to, put out the value e raised to minus 2, which is equal to 0.1353. So, here we get 3 into 0.1353. When we multiply 3 by 0.1353, we get 0.4059, 0.4059, which is equal to 1 minus 0.4059 is equal to 0.5931. This is the probability for at least 2 defectives may be found in the package. Okay? Now, we will see next example, that is example number 6. An oil exploration firm finds that 5% of the test wells it drills, okay, yield a deposit of natural gas. If the firm drills 6 wells, what is the probability that first exactly 2 wells yield gas and second at least 1 well yield gas? Okay. Solution of this: probability that first we find out value of m, and for this probability that a well will yield a deposit of natural gas which is equal to, here we have given that 5%. 5% means 5 divided by 100, which is equal to 0.05. But here also given that there are drills 6 wells. So, we have to multiply the value 0.05 by 6, and first we write, since the probability is small, we may R Poisson distribution. Here m is equal to 0.05 into 6, which is equal to 0.3. And here we have to find out probability that exactly 2 wells yield a deposit of natural gas. Probability that exactly 2 wells yield a deposit of natural gas. Which is equal to e raised to minus m raised to x divided by x factorial, which is equal to, here we have to find out 2 wells, that is x is equal to 2. Put out the values, m is equal to 0.3 and x is equal to 2 in this equation. So, we get e raised to minus 0.3 into 0.3 raised to 2 divided by 2 factorial. Okay. Which is equal to e raised to minus 0.3 into 0.09 divided by 2 factorial, that is 2. Then when we divide 0.09 by 2, we get 0.045, here I am right, which is equal to 0.045 into e raised to minus 0.3. But in this question we do not give the value of e raised to minus 0.3. So, we write, here we write only e raised to minus 0.3 as it is. Okay. Now, for second, at least one well yield gas, probability that at least one well will yield a deposit of natural gas. So, here we have to find out 1 minus p of 0, that is for x is equal to 0 we have to find out the value of p of 0, that is 1 minus e raised to minus m, that is e raised to minus 0.3 into m raised to x, that is minus 0.3 raised to 0 divided by 0 factorial, which is equal to 1 minus e raised to minus 0.3 into e raised minus 0.3 raised to 0 is 1, 0 factorial is 1. So, here we get only 1 minus e raised to minus 0.3. This is the probability for at least one well yield gas. Now, we see next example, that is example number 7. A radioactive sources emits on an average 2.5 particles per second. Calculate the probability that 2 or more particles will be emitted in an interval of 4 seconds. As usual, first we find out the value of m, that is m is equal to, that is mean, which is equal to m, which is equal to 2.5 particles, that is here 2.5 particles, but for 4 seconds. So, here we have to multiply 2.5 by 4. So, we get 10. This is our value of m, that is m is equal to 10, and here we have to find out probability that 2 or more particles will be emitted in an interval of 4 seconds. That is, here we have to find out first probability of p of 0 and p of 1, and we have to subtract the value from 1. So, first we write required probability that 2 or more particles will be emitted in an interval of 4 seconds. That is, we have to find out the value of 1 minus p of 0 plus p of 1, which is equal to, here I am writing p of x is equal to e raised to minus m into m raised to x divided by x factorial. 1 minus, here x is equal to 0. So, e raised to minus m, that is minus 10 into m raised to x, that is 10 raised to 0 divided by 0 factorial, plus e raised to minus 10 into m raised to 1 divided by x factorial, that is 1 factorial, which is equal to 1 minus e raised to minus 10 into 10 raised to 0 is 1, 0 factorial is 1. So, here we get only e raised to minus 10 plus e raised to minus 10 into, here the value of m is 10. So, here we get 10 raised to 1, that is 10 raised to 1 is 1, sorry 10 raised to 1 is 10, 1 factorial is 1. So, here we get 10 into e raised to minus 10, which is equal to, common out e raised to minus 10 from this equation. So, here we get 1 plus 10 and 1 plus 10 is equal to 11. So, 1 minus 10 plus 1 is equal to 11. 11 into e raised to minus 10, that is 1 minus 11 into e raised to minus 10 is the required probability for 2 or more particles will be emitted in an interval for 4 seconds. I hope all of you understood these 3 examples. In next lecture, we learn about more examples related with Poisson distribution. Okay? Thank you.